So I see a lot of happy faces. It looks like you're having a good conference, good talks, good food, good colleagues around you. So that's cool to see. I think it's the first time that droidcon takes place here, and I think they have put an awesome event in place here. So it's great to be here. So by now, Android and Gradle, the Android robot, the Gradle elephant, have become pretty inseparable from each other. And so it makes sense for every Android developer to have a good understanding of what part or what role plays Gradle in that game. And that's what I would like to share with you a little bit today, give you more insights about Gradle. And I would like to do so from the perspective of performance. Right? And I assume everybody in this room cares about performance. And this is not about performance of your Android application, but performance in terms of your build. Right? Or is there anybody in the room who has a build who is too fast? Nobody, okay. Otherwise, come up to me and tell me how you do that. But before we get started, just a short show of hands. Who's doing Android development? Okay, well, that wasn't too hard, right? I would say like 95%. Who of you is using an Android 2.x or Android Studio 2.x version? Oh, that's again probably the same amount, like 90%. Who has actually touched their Gradle build files of an Android project? Ooh, a lot of hands. I would say like 50, 60%. That's awesome. You're better than Zurich. We had like 3 people raising their hand. And who has been using Gradle in a project besides Android? Some other project? Okay, still a few shy hands. Maybe 10 people. Cool. All right, so I hope I can give you can get you a bit closer to maybe touching your Gradle build file and not being scared of it. First, let's take just a brief look at the motivation. Why do we make such a big deal about the build? Why don't we just write a few shell scripts and call it done? Why is there so much energy behind it, so much effort behind it? So a few facts to start with, and I guess you're all very intimate with those, is the domain is very complex around Android. And you have things like resource generation, you overload those resources, you have multiple languages involved if you do like a full project usually. You have different platforms that you have to deal with, something you all know much more about than I do. So all in all, it's a pretty complex domain. And what is the challenge when you want to build your project in terms of complexity? It is you want to be very expressive, but you also want to be very concise. And that is almost like a conflict, and that's a conflict that Gradle tries to solve, or I think it does solve it. So if you look at Maven, very concise, but not very expressive. So as soon as you leave the standard, it becomes pretty difficult. Ant, very expressive, but not very concise. Who of you has used Ant? Okay, a few. Okay, probably more the people my age. No, not just kidding. But it's been quite a while since I've been using Ant, and at the time it's a great tool, but really the challenge is in the expressiveness that is there, but then you lose the conciseness. And so here's a very simple example from the Android world, an Android build, where we define some product flavors, and we define them along 2 dimensions. And so very compact what is described here, but if you look at what's happening behind the scenes, I'm not sure if you can read it in the last row of the audience, but there are more than 200 tasks being generated in your Gradle build when you define such a build. So a ton of stuff is happening, but all this is really hidden behind this very concise, but at the same time very expressive DSL that you have available. Right, so Android is a really good showcase of what Gradle tries to preach, basically, although we're not religious in any way. We're also in a very polyglot world, especially in Android, I would say, but not just by using different languages, but also by having multiple teams, maybe having multiple locations, multiple continents, like we have at Gradle, for example. And what's key about that is that in the end, you still want to make one product. You want to build one release. So all these things have to come together from different languages, different teams, different locations. So this coordination needs to somehow be mapped to your build. And what you deliver to finish this off, is not just really building an APK, right? There's a lot more to it today. You want to provision whole environments. You want to run your tests that are testing your code that is then sample code in your documentation, and so on. There's a ton of stuff you want to do as part of delivering a project. So you need a tool that allows you to map this. To give you some concrete numbers from LinkedIn. So LinkedIn switched to Gradle a few years ago because they were very ambitious in terms of what they wanted to do in terms of continuous delivery. And so they have like 2,000 people working with Gradle on a daily basis. They have like 2,000 components, and these numbers are already maybe a year old. They do like 300,000 executions a week of Gradle and about 1,000 releases per day. Now these numbers are only possible because they use a build system that allows them to coordinate and map such a complex environment. Right. So let's dive a bit more into the details of the Android build system and how that corresponds with, or how that interacts with Gradle. So we have basically 4 components. You have the Android Studio, you have the plugin, the Android Gradle plugin. Both are coming from the Android team. You have the Gradle platform, that's coming from the Gradle team, and you have the Android tooling, right? So this is roughly the 4 components that are in place here. And what I would like to take a closer look at is just the Gradle plugin and the Gradle platform. And I think it's also important to know who does what, because if you have a problem or a question, you might get a quicker answer if you ask the right people, right? So if you have a, let's say, indexing problem, you don't have to come to Gradle. That would be not very helpful. But with other things, Gradle would be the right address to ask questions. So very central to the philosophy of Gradle, and it's really mapped nicely in Android, is the philosophy to have a single source of truth. So you don't want to have build logic in your build files and some more logic in your IDs. Right. That used to be in the past. As a developer, you would check out the project, and then you would spend half a day setting up your ID, adding libraries, configuring settings, etc. But that's not how it should be. All should be in the ID, and when you import the project, everything is set up. And you get that really nicely from Android Studio. So it's a very good example, or a very good implementation of how it should be. So let's take a look at how those things play together. What you can see at the left top is the Android developer, could also be any other kind of developer, who wants to run something to Gradle. And that happens through the tooling API. That's a small client library, it's like 2 megabytes or so, that will forward all requests basically to the Gradle daemon, which does the actual work. And the reason I'm showing this here is if you are on the command line and you invoke Gradle, you end up talking to the same Gradle daemon in the end. Or if you're a continuous integration server and you run a build, it will again invoke the Gradle daemon that does the actual work. So it's again a single truth, or a single source of truth, which is your build file executed by the Gradle daemon, no matter where you come from. So just a few more details about the tooling API, and I think that should be interesting for every developer. As I said, it's kind of a proxy for embedding Gradle. So that little library itself doesn't have any logic in it. It just forwards via inter-process communication with Gradle. And it has an extension mechanism, and that's what the Android team is using heavily. What they want to do is they want to extract certain information of what is described in the build, such that they can map it to the ID. Right? For example, your flavors, they want to show you the flavors in the ID. That's something IntelliJ IDEA by itself doesn't support, but the Android Studio does. And the way it's possible is because the Android Gradle model exposes that information, and then they can map it to the ID. The special ID, of course, but anyway. So if you're interested more, what does the Android plugin actually collect from the build? There's a class default Android project model that kind of lists all the information that is gathered and then sent to the ID. Right. And to finish this off, what's very powerful about it is it's backward and forward compatible. So even if you use Android Studio and it ships with, by default it says use Gradle version 2.10 or whatever it is, you could still give it a try and use 2.11. So those versions are not kind of tied to each other. There's runtime isolation. So let's say there's a leakage in Gradle, it wouldn't affect Android Studio, and the other way around neither. There's also some high-level services. You can cancel a build to the tooling API, which means it doesn't just shut down the process, it tries to do this gracefully. Right? There's a continuous mode, and I'm going to show you that in a second, unless you all tell me you know it, which would be the first conference. And there's also test execution, and that again shows that idea. If you run tests, it shouldn't be the IDE that runs your tests, because maybe as part of running your test, you have a test set up and you have a tear down. Maybe you bring up a server or some other services. So it should be the build running them, right? So, but as a developer, you don't really care. You just want to see what's happening while you run the tests and what is the outcome. And that is possible through the tooling API too. And I think that Android Studio will make use of that at some point, right? Which means you want to run a test. The tooling API will tell Gradle, run that test. It will run the task that includes that test. It will do all the setup and tear down. And then it will report all the results kind of in a streaming mode back to your IDE. So this is all implemented in BuildShip or Eclipse integration, not for Android, but just for standard Java development. That's already there. So it's basically just up to the Android team to use it. And if it's not yet having all the details that it needs, then we can extend them. Right. Okay, so that was a bit of a deep dive into the tooling API, and now we're going to go out again and look at performance, and of course in the context of Android. So what is our goal in the end? We want to have a build that runs as fast as possible and uses as little memory as possible. Simple goal, hard to achieve. But our observation we can make, and I'm going to come back to that several times, is when you invoke a build, you make a change, you invoke it again. Typically between those invocations, not much changes. And if not much changes, and by that I mean maybe a few source files, a few resources and so on, then not much should happen in terms of work that the build does. Right. If you change a lot, of course, a lot should happen. And how can we get there? We can get there in two ways. We can either do evolutionary changes, or we can make revolutionary changes. Or, of course, we can do both at the same time. Right? And that's actually what we're doing at Gradle. And I would like to show you some that we have already done and that we're going to do soon. Both evolutionary and revolutionary. So if you look at the Gradle build today, how it's working, it's basically two phases. You have a configuration phase and you have an execution phase. Is everybody familiar with those two phases? Yeah, so some people seem to be. Okay, so basically in the configuration phase, your build is parsed, it's interpreted, and a task graph is built. And in the execution phase, those tasks are executed. Right, so it's like a preparation phase, and then once everything's prepared, things are executed. And I would first like to take a look at the execution phase. So what do we do there in terms of performance, which is already better than most build systems out there is? It's called incremental build feature. So I'm going to come back to this, what I said before, if nothing changed, nothing should happen. If little changes, little should happen. So if you have a task that does some work, that task has some input, maybe source files or some other resources, and it has an output. And if the if the input doesn't change and the output doesn't change, next time you invoke it, or hasn't changed, nothing should happen, right? So you have source files, you compile them. You compile again, well, it shouldn't really compile because nothing has changed. So this concept of a task being a function of inputs that creates an output is what this feature is about. And it's super powerful. Right? If you have a very big build and you just run Gradle build and you run it again, it should just tell you up to date, up to date, up to date. If you ever define your own tasks, for those that said they have already touched the Gradle build file, make sure you also define on your own task, what is my input, what is my output, because then Gradle will take care of it, manage all the caching, the remembering, and it will take part in the incremental build as well. Just to give you an example, so we need to have some code, right? This is a sample task called conversion task, and it doesn't really do anything. If you look at do some work, it's empty because it's not about what it does, but you can see that the source files are annotated as input files, and the target directory where the result is written to is annotated as output directory. And so if you then instantiate or declare an instance of that task, I called it foo, and you say, here are my source files, here's where I want to put it, and then you run that task, it will do something. If you run it again and you didn't change the input or output, nothing will happen. Right? Or nothing will happen, it will just say, I don't have to do any work. Right? So continuous build. Continuous builds, who knows them or who has used them? Okay, it's like 2 hands in the whole room. 3. Just increased by 50%. You had a lot of weight in there. So I'm going to show you that in a second. So the idea is you run a build, and when you have run the build, it will not kind of finish, but it will keep the session open. And it will just wait for changes to these inputs that I said. So each task has inputs. And if one of those inputs changes, it will re-trigger a new build automatically. Right, so you can make changes to your code, they're picked up, and it rebuilds your project. So it's also very powerful, for example, for web development. You make some changes to some web files. It rebuilds whatever it needs to do as part of those tasks in continuous mode, and you have an instant new version of your application. Okay. And I'm showing you this in the context of performance, and I'm going to show you in a second why. So let's go and do something. Yeah. So I'm going to say Gradle test -t, and that's the secret. It's the -t. I'm going to just call the test task. I could also run the build task. Doesn't matter. That I say GR is just because I have an abbreviation I defined for it, an alias. Okay. So now what happens? It runs your build. Oops, something failed. There was a failing test. Okay. And now we can go and we can fix that test, obviously, right? So let me go over here. Have it open. Yeah, I made a little typo here on purpose. Let's fix it. So I changed that file, which was part of the tests that were run. I press save. And if I now go back to my console, I can see that a new build was started. Right? The other one didn't even, like the session was still running. And so the benefit of this is as you do changes, Gradle will keep track of the changes. As you make changes, it will keep track of them and rerun your build. And the benefit of that is your VM remains warm. Right? So instead of having a cold start each time, that VM is already there running. It also applies to compiling. If you have a compiler task and you spawn a separate process for it, that will remain alive as well. So if you run again the build because you changed something, that compiler process is already warm and running, and it will be faster as well. Right? So keeping things warm is really important, and that's one thing you get out of this control, this continuous mode. Okay, right. So let's go back to the presentation. So what have we done in summary for the execution phase? So the incremental builds over time got a lot faster because the way to check for changes has improved drastically. So I mean, we never looked at just timestamps. It's always a combination of checksums and file lengths and so on. But there's a lot you can do. And if you have projects like Unity, like the gaming company, they have hundreds of thousands of source files. And if they run the build twice and they didn't change a single source file, the Gradle build has to detect that as quickly as possible. Otherwise, they wait. I'm just giving any number. Let's say they wait 10 seconds just so Gradle then tells them, oh, okay, the task is up to date. So if nothing changes, that has to be super quick. And so there's a lot you can do depending on the JDK you use and so on. Compilation does get faster through the continuous build. As I told you, when you run in continuous mode, the compiler process that is spawned off is kept alive between instantiations or running invocations of the build, so that makes it faster as well. And it makes a big difference. So these are all evolutionary improvements that have gone in the Gradle build. And as an Android developer, you benefit from them automatically. Right? There's nothing special about Android project or not Android project. Everybody just gets them. If you look at the configuration phase, and that's probably very interesting for Android people, even though you have a very declarative model, what's currently happening behind the scenes is quite imperative, which means Gradle doesn't really know much about what is behind that model, because the imperative code is kind of impossible to analyze for Gradle, which means the Android team that develops the Android plugin or the Android Gradle plugin, they have to use a lot of tricks to make it work with such a nice little DSL. But Gradle itself doesn't then have any way to optimize it because it doesn't really know what all that code is in the Android plugin. Right. So one side effect of that is no matter what you invoke, the Android plugin has to build basically everything. Right? And we don't want to do this, right? If we just want to build some things, it shouldn't have to know everything. That comes back to what I said in the beginning. It's kind of the reverse situation today. So for Android, the full model has to be constructed even if you say Gradle help or Gradle task, which is not good. It also has to do full dependency resolution for certain reasons. Without going into those details. And really it's hard for the Android plugin to know when are things done. When are you done with your flavor declaration and so on. Right. So what can we do there in an evolutionary way? The faster build script compilation, that's already in place. So we now cache what has been compiled of the DSL because underlying is Groovy and it creates bytecode, so we can cache that. There's also this mode of configure on demand. I'm not sure if anybody has already used that. Configure on demand, cool. So it's just an optimization that allows you to run a build, and Gradle will try to only configure the minimum needed. Right? It's incubating that feature, so it's kind of beta, but it works in many situations. Does it work for you?
Fairly well, yeah.
Cool. That wasn't set up. Right? So these are evolutionary improvements, and they just come with every Gradle build, and everybody benefits in the native world, in the Java world, and in the Android world. Right. So let's take a look at very specific Android builds. So we have a sample application trying to mimic something real. Of course, there's a whole bandwidth from small to big. But just to give you some percentages here. So if you do a clean install, CNI should be in lowercase, but that's the autocorrection that got into action here. If I do a clean install, what the Android plugin has to do first, it has to dex all your dependencies. So not your own code, but the dependencies you are using, depending on the tooling version and so on. And that takes time. That's why when you do a clean install, it's almost half the time here. And next time you call clean, it will take again the same amount of time, because those text libraries are not safe from being cached, or from being thrown away, I should say. They're not cached beyond calling clean. So what can we do there? What we can do is we can have a kind of a cache, just like we have for dependencies, that will keep your text results. Right? And that's something that will come soon. We can do the dexing of those libraries or those pre-dexing steps in parallel. And we can use a distributed cache. And the distributed cache is another thing that is already being worked on right now. Not in the context of Android, but you will just benefit from it without any extra investment or extra work that you need to do. And there the idea is, let's imagine you have a big project, you have a lot of libraries. Every developer that checks it out the first time and runs a build, all that pre-dexing has to happen for all those dependencies. You do it clean, you lose it all. With a distributed cache, whoever runs it first will put it in the Gradle in that distributed cache. I mean, not manually, of course, the Gradle itself will do that. And then after that, everybody else that runs the build will first ask the local cache and then the distributed cache, is this already dexed with all those constraints, those different tooling versions, etc. And if that's the case, it's just going to reuse it. So it means only one guy or one machine in the company will do all that pre-dexing, and everybody else will then just benefit from it. And if you do it clean, you don't lose anything neither. Right? And there's not that much need to do it clean, but it still tries to emphasize the whole idea. Okay, so this was the pre-dexing. Now let's say we have done an install, now we make a code change, and now we wanna install it again. What we see is that a lot of time is happening now in the dexing. And there's not really much that Gradle can do, right? Even though we're often asked, but we can't. It's not our domain. So Android Studio 2 already has faster dexing. Future versions will even have more dexing. So there's a lot of power going into that. So pre-dexing, Gradle can do a lot. Dexing, Gradle cannot do much. So let's take a look at some statistics. If we look at the dexing with Android Studio in this sample project, it went down to about 25%. Okay, and that's the pure merit of the Android team. Now, we got this initial pre-dexing down, but now we want to do some debugging, making some changes to the code, and we want to redeploy the application, right? Okay. So if we take an old version of the Android Studio, like 1.4 or 1.5, doesn't make a difference. It has an older version of the Gradle plugin, the 1.3, and we run it. So we make a change, we redeploy. We can accelerate that because it's going to take quite a while. It's going to take like 27 seconds. Right. That's not very fluent way of working. If we take the Android Studio 2.0 or preview, doesn't matter. I didn't want to change all these numbers. We can run that again. And we don't have to wait this long. This time it takes like 3 seconds. So it went down from 27 to 3 seconds. And again, most of this is really, what I showed you is the merit of the Android team. So they have this instant run, which does like a replacement of the code without doing class reloading. It also has some special Gradle tasks. Because you are in the IDE and you make a change in the IDE already knows what you changed. So when you invoke Gradle, Android can short circuit some of the Gradle tasks, so Gradle doesn't have to check the same things again. Because Android Studio already knows this file has changed. So Android can automatically, for example, trigger a certain task without going through the up-to-date check. Right. Obviously this only works in Android Studio and doesn't work with all changes. Okay. The new emulator brings it down some more, about half. And then with the cold swap, it gets down another half. So if you look at the stats here now, the dexing came way down, as well as the install step came way down to like a fourth. And what's really interesting about the statistics is what is now becoming more relevant is this other part. And this other part is where Gradle is in. And if all the things before it are optimized, that other part becomes much more relevant. Right? Before, the dexing in install was 13, so 3.6 doesn't really make much of a difference. But if the rest takes only 3.5, well, 3.6 is even more than that. And so the cool thing is that everything we tweak now in Gradle has much more impact or is much more visible because of all those great things that the Android team has already done before that. Okay, and you can see that in this graph here. If you look at Gradle 2.1, which is the blue graph, and you look at Gradle 2.9, and by now we're at 2.13, so this graph would have been even lower. You see that the other part went down as well. Okay. And so that's just a journey that's going on. That's 2.9, we're now at 2.13, and Gradle has a full team that just works on performance. So they sit in front of the compiler, the profiler, and other tools all day long and just optimize everywhere. And there's so much you can optimize based on the JDK, based on the OS, based on your implementation, and so on. So more is coming. All right, so now a little bit of a mental exercise, and that is the revolutionary change. I showed you this evolutionary changes, like tweaking here, tweaking there, making local maxima possible. But there's also a revolutionary change ongoing, and that is to only do the least that is necessary to do the work. Okay, and I'm going to show you some graphs in a second. But that's different to how it was before, which is the strike-through line. Build everything, and then you just want to build up everything, and then just build one variant. Right. And really the idea is to do the same as in the execution phase. So you have some inputs, you have some outputs, and if they haven't changed, you don't need to build anything. Right. And that's done in a declarative way, and we'll see that in a second here. And it will allow us to do richer modeling, cleaner modeling. You can also be more collaborative. So if you want to write your own Android plugin, right now that's pretty hard, because every plugin that does something with Android wants to be the last one to do something. But only one can be the last one. So with this new model, it will be much cleaner and better possible to collaborate. You say, I have this plugin, but I also want to apply some other plugins, and they work together nicely. And the reporting, of course, can be much better too. We'll see that. So just to give you a very short example, then we move on. If you have like a model, you just define an interface, and Gradle will provide the implementation. And that is kind of a key idea about Gradle is you want it to be declarative, so that Gradle can reason about it. Because if it can reason about it, it can start caching things, it can start making things parallel, and so on. All those models you create, you can then define as rules, how you want to modify them, how you want to create them, and that goes into a plugin, right, called rule source. And that's how the DSL looks. So it looks, you can see it's already modeled at the top. That's what you have in the Android experimental plugin as well. Okay. And the cool thing is about the whole reporting. If you have a complex build, you can really understand much better who modified and created what. Right. And that can be very useful if you have a big build. But that's only possible if Gradle knows the details, and then it can do the reporting for you. But if it's all just imperative code, like it is today, it's really hard. Okay, this is probably the coolest graph about this whole new approach is you can see in light blue how long it takes to make a full build of a project, of an Android project. It's at 15 seconds or something. If you build only one project, it's like 13 seconds. And if you build only one variant, it's maybe 12 seconds. Right. That's the current model. Now with the experimental model, you can see that the dark blue is always lower, right? So it is faster by default. But that's not really the key that I want to show you. The key is, if you look at how much time does it take for build all, how much time does it take to build one variant or one project, that number goes way down. Right? And that's exactly where the meat is, basically. Right? If you only build one variant, that should be much less work than building the whole project. Right? That's where this new experimental model gets us. So Android, when you install the Android plugin, you already have kind of two plugins available. The old one, or the old one I should say, the current one, and the experimental one. Right. And at some point the experimental one will become the default. And that experimental one is based on that new model that I just showed you. So you get all the benefits that I explained once this model becomes the default. Has anybody already used it? Oh, now Zurich is ahead. We had a few people that actually used it before. And when I was in Sweden, there were actually some people that used it in production, which I found pretty impressive. So experimental doesn't mean it's just give it a try and then throw it away again. Depending on your circumstances of your project, you might actually use it in production. But it's not really production ready officially, right? The disclaimer. For example, the DSL could be improved. There are certain quirks, like you see this create QA, that could be nicer, and so on. And some deeper stuff like dependency resolution and so on that are currently worked on. So it's just a matter of time till this will become the default. And then you will see the big jump in performance. And until then, you get those increasing improvements with every release of Gradle and every release of the Android plugin and every release of the Android tooling. Okay, so to summarize this new configuration model, because it is so declarative, things can happen in parallel. And if you can do things in parallel, things can be fast. And at some point, Gradle will have a distributed build, not just a cache, a build. So you have your build machines, and when you run the build, it can do the work across build nodes or agents. And that's only possible if Gradle knows what are the dependencies between those tasks, what are the dependencies between the configuration aspects. Right? Those types that I showed are externalizable. Externalized means they can be stored, they can be reused, they can be cached, and so on. That's really the revolutionary change. So trying to get you a bit excited about this new stuff. So to round this off, and this is not specific to Android, but I want to show you that not only in the Android world do you have the concept of variants, even in the Java world you have this concept. And we'll see it here. We define a little project based on this new model where we define a service. A service is something that offers an API that somebody else can consume. And you can see towards the bottom it says API and exports a certain package. Right? And under dependencies you can see library and you can see exported through for the first line in the dependencies section. Okay, so we're defining a service and we're exporting something for the consumer. Okay. Does that look familiar to some of you people from the Java world? Have you seen this in another context? Sources? Services. Yes, services, yes. The one I was thinking of is like Jigsaw. Right? It's going exactly that direction, where you define what you expose, what others can consume. And you can also see towards the bottom, and that's where the variants come into play. You can see target platform, Java 7, Java 8. So when you build this service, it's going to build different flavors, basically, for those different target platforms. Okay, and there's another side to that story that I want to show you next. So keep that in mind, what we talked about. We now have a client that wants to consume that service. It wants to invoke that service. So it can say in its dependencies that it wants to consume the service. You see that in the dependencies section. And it also defines some platforms. So that's going to give you variants as well. And now what will happen is, if you say, I want to build a variant for Java 7, well, guess what version of the service will it use? It will also use that variant that is built for Java 7. Okay. And that is something that will apply to the Android world as well, that if you have a debug version of your project, that it also consumes the debug versions of the dependencies you're using, all the way to your native dependencies, that it's also using the debug version, for example, or whatever variant it is, or whatever flavor it is. Right, so transitively applying the right flavor of your dependency. So what is the roadmap in that regard? Those improvements that I said about performance, so evolutionary and revolutionary at the same time, and to generify this dependency management, like I said, around the variants. And how can you do this? Just in short, you can, of course, apply fix hotspots. You can do caching. You can do stuff in parallel, and you can do stuff in the background. And we've seen this already applied to the task execution a lot. So if you look at the right-hand column, we already do a lot of stuff in the background. That will be your process that is keeping running, the daemon, the compiler daemon. We do stuff in parallel. We can cache stuff, like the incremental build feature, and we can fix hotspots, obviously, with each build. But we can do the same to the build configuration phase and to dependency resolution, like I just outlined. So dependency manager is really doing it for all your variants across your transitive dependencies. Okay, so to kind of close this was a kind of a look at what's currently the state, what are the numbers, what are we doing. We're also working on something that I think is going to be really useful for the Android world, and that is kind of something that is in the SaaS, which is about when you run the build, it's collecting some data about your build. And that data is uploaded to a server, and then that data can be shared. It's visualized and it can be shared. So if you want to know some insights about your build, going to that web page that represents the captured build data will give you insights on how you can fix issues, how you can improve issues, and so on. And so I can just give you a small glance at this. So we haven't really launched this. This is from my friend here, Cedric. But it's working. So you would see, when was it started, which time zones. You can see all the tasks. You can also see the console output. Here, you can go through all that. You would see your failures with high-level information about your failures. You see all the projects. Here you see the Gradle build, by the way. So quite a few projects there. You can see all the dependencies. And of course, you can drill into those dependencies. Yeah, and you can see the plugins that have been applied, and so on. You can see which help task maybe is not the most interesting one, but who applies the Java plugin, and so on. And that's just the start. So there's going to be even more of those insights, not about just telling you the facts, but also telling you how you can improve things. Or maybe you have dynamic versions, which can always be a problem. Or maybe you want to compare your build to the one you had yesterday, because yesterday was green and today is red, but you didn't change anything in your code. So what happened? Right? So you're going to get all those answers via that tool. And we get a lot of questions from the Android people like, oh, my I don't know, my build is slow. How can I fix this? And what do people do? They come up to me with their laptop after the talks, like, can you please fix my performance problem? And I like to help, but it's usually a bit of a challenge. But with something like that, basically all you need to do is share a link in the forum and say, can you take a look at it? And at some point, you don't even need to ask anymore. The tool will tell you yourself. All right. Yeah, so to finish this, I have a little quiz. And I have 2 T-shirts to give away if somebody wants to have a T-shirt. Maybe you're already flooded with T-shirts from this conference, but they're not Gradle T-shirts. Those ones are. So I have 2 questions. And if there's more than one, then we'll have to see what we do. I can't rip it apart. So back to performance. You have a build, and I don't know. You don't know what's going on. It seems slow. How can you find out more? Is it my tasks? Is it my configuration phase? Maybe it's a test that is long. How can I know more? Well, in the future, you would use Gradle.com. But what would you use today, like the SaaS offering I told you? Today, what would you do, besides coming up to the stage and asking me? Yes? Yes, okay. There's -- profile on the command line. Who already knows that command? Okay. I'm glad it's not everybody's. We would have to order more T-shirts. So, yes, if you want, you can have a T-shirt. Sure. You can even choose which one you want. Yeah. They're both the same size. You can have this one, or you can have this one. The elephant one. All right, excellent. We gave some away at the NDevCon in Santa Clara or something last December. And the deal we made is if you want to have a T-shirt, you had to put it on right away. I mean, you could go change. You didn't have to do it in front of everyone, but you had to walk around. So by the end of the conference, I would say half the people had a Gradle T-shirt on, which was pretty cool. All right, but this is really important. That's why I put up this question. If you want to understand better where is the time currently spent, run your build from the command line with -- profile. And it will give you a nice HTML report saying this is the configuration phase, this is the execution phase, that task took the longest, and so on. All right, that's the spirit. He already is wearing that T-shirt. Nice. Cool. All right. So I have one more question. So you didn't know the answer, but next time you want to know the answer. What do you do if to find out more about what you can do from the command line? Run help? Yes. Okay. But I would not underestimate that, because if you go there, you see maybe 20 or 25 options, and there's a lot of cool stuff there. There's stuff like you can run in parallel, you can run configure on demand, you can say rerun the tasks even if they're up to date. So there's quite some information that you can get there without having to browse on Google. Right? So I would really keep that in mind and maybe take a look at those options. It's not overwhelming, 20 or so options. I heard you first, so I'm gonna give you that one. Thank you. Cool.
I won't put it on right now because I'm speaking next and people will get confused.
Yes, so he's speaking next and doesn't want to put it on right now. Well, if you didn't know the answer, but next time you want to know the answer, for example, you could do like an open, massive open online course. There is one specifically for Gradle and Android, and it has been done by the Gradle team together with the Android team. So this is quite a course to get there. I mean, to make it. happen with all the experience from the Gradle team and the Android team, the Google team, I should say. And it's a great course. So you can learn about Android as well as Gradle when it comes to the build. So I can really recommend that. Another way is we have a Gradle Summit, so for 2 days in Santa Clara, where everyone comes together, including Android people. So like Xavier Ducoy, the head of Android tooling, will also be there and talk. Right. It's a nice place, California. Right. Oh yes, and the usual slide, Gradle is hiring. If you're really excited about build automation, come get in touch with me. All right, thank you for your attention and have a good rest of the conference.
Any questions for Mr. Studer? Maybe? Oh, yeah, you have some. You're not done yet. You're after the coffee break.
Hi.
Hi.
Can you give us an estimate of when the Gradle software model, so the Gradle experimental plugin will come out of experimental phase and become the default?
For Android or in general?
Both in general and Android.
Okay, I cannot give you a definite answer for both. Sorry about that.
For Android then.
But it's hard to make a commitment because it's a super complex undertaking, because we want to keep compatibility with what's there. But I would say like fall,
will it be
winter.
this year or next year or?
Well, I think we could be
years?
happy if it's by the end of the year.
Thank you.
But take that really as a like this. Right? But what's really cool is that the Android team, they want to have it. We want to have it for them as well as for like native support and the Java support. So everybody wants it, the users want it. So it's really just a matter of getting it done, besides all the other things we can do from distributed cache to and so on. Right. So, but I think don't expect to be by summer. Be hopeful for winter.
Okay, based on that, here.
Ah, yes, hello.
Can you tell us how to use that experimental plugin right now? You know, while we're still in the experimental phase, is it is it another version of it?
Is it what?
Is it another version of it that we used in base of the Android project in Android Studio? How do we turn that experimental features?
I mean, when you apply the plugin, it's in there. You just have to define the model the new way, basically. And I think I'm not sure if it's written on the Android page of how to do that. Like,
okay, thank you.
I cannot give you more
information.
Yeah, not more details, but it's written somewhere. Like it's not rocket science, right? You just have to know how do you apply it, basically. And I don't know by the top of my head.
Okay. And can you tell us about that sorry, I forgot the name. Continuous mode. Is it turned on by default when you build an Android project?
No.
But when I build it for the command line, I use it at /r if I...
/t, -t, yes.
-t, and then it's turned on.
Yes.
Okay, great. Yeah. And the last one, I promise. That distributed cache that you mentioned, that's something that's coming up.
Yes.
Yeah, well, where will that cache be stored? On the server, with that Gradle server or our local server, or how do you plan on
I would say it's not in that sense finalized yet. It's under work right now, and you can see it on certain branches of Gradle, so it's all open source. But where it lives, I mean, it will live somewhere, and at some point it might even live on multiple servers to have some redundancy. But it's not necessarily meant that it lives on your machine, right? Yeah. It lives on some machine. That might as well run the build, maybe the continuous integration server, but it will just be accessible from within your network then, right? So it's not mature enough to make those detailed statements yet for me. Yeah.
Thank you.
Cool. All right. I think we should let the next speaker, who doesn't want to put on the Gradle t-shirt, a chance to get ready. Have a good rest of the conference.
Thank you very much.